Hello, this is Kristen Billiar at Worcester Polytechnic Institute, and I'm going to be talking about how to use the extensometer with an Instron 5544 mechanical testing machine, and it's using Bluehill 3 software. So this is what the extensometer looks like, and it has two pieces on here that move apart to measure displacement, and displacement also can be measured in the machine using the extension or LVDD inside it. But if you want to know the local strain of a material, you need to use this extensometer. So first thing you have to do is plug the extensometer into the machine here and let it register. Well, it self-registers, it has electronics inside it so that it can self-identify, and that comes up in this part of the program. When you open that, you can calibrate the instrument and look at its gain, its limits. So right now you can see here from the strain that this has a 25.4 millimeter gauge length. That is the distance between the two claws there, points. And I'm going to use an automatic calibration. Again, that's already self-identified when I plugged in the extensometer. And by doing what I do is there are two pins here, and there's a point inside where they match up. When I hold that button down, and now I've gotten it to exactly 25.4 millimeters, and I hit the calibrate button, and it tells me to set it to its gauge length position. It is calibrating electronically. Now it's calibrated. Now the full scale of this is 12.7 millimeters or 50%, so I don't want to go over 50% strain with this. And there are points in the program where you can tell the program to stop and take off the extensometer, such as in a failure test. You could get the sub-failure region and then take the extensometer off. So I have a leather sample in here. I'm going to bring it up to a tear load of about 10 newtons, so it's nice and taut. I've already set the safety stops, and I've calibrated the transducer, and now I'm at a load of 10 newtons. I'm going to zero my extension there, and that I've zeroed an extension, and I've zeroed my tensile strain, but my extensometer says there's a slight negative strain. I'm going to put the extensometer on using the two-hand method, which is appropriate for soft materials like leather. I hold it in its calibration point, so at 25.4 millimeters, and I pull out the two tongs here and put it on the sample at one time. Now I'm holding that at 0, and as you can see, the extensometer strain on the screen here shows 0 strain. Now when I let it go, it'll go to some small amount of strain. The tension on the extensometer can be changed by using, if I have a thick sample, I can use thick grips here, the wire clips. If I have a circular sample, there are different wire clips. These are for a circular sample. They look very similar, and I can show you in the manual. Clips for round specimens have an extra little piece ahead there, and clips for rectangular specimens look a little bit different. I've put in the clips for the rectangular specimen in here for a thin sample. My sample is about 1.5 millimeters thick, so I put in the smallest grips. So now using a stress relaxation test, I can test this. So if I go into my method, I have my sample, which is rectangular, SI units, and the measurements I can take now with this are time, extension, load, and tensile strain as usual. But I can also put in extensometer strain, and that's what I've named it. It's actually called strain 1 when I first put it in. I can name it anything I want. Extensometer strain with small grips or wires, but I'm not going to do that. I'm just going to call it extensometer strain so I know the difference between tensile strain and extension, which is just the displacement measured by the machine divided by the gauge length, and my extensometer strain. I can, when I do stress relaxation, I can do different measurements along the way. Now I'm going to do test control. Now when I do the start of a test is by a start button, but by strain, now I not only can do extension control, but I can do extensometer strain. So I could run my test at, let's say, 1% strain per second using the actual local strain from the extensometer. I can also remove the extensometer during the test and say, when I do get to 12 millimeters, stop the test, and I can take it off so I don't break the extensometers. Now that's extension of the machine, not of the extensometer. So I could say, when I get to extensometer strain of, let's say, 12 millimeters, and I know it can go to 12.7 millimeters, take it off. In this case, I will leave it at the extension of 12 millimeters. I know I'm going to stop the test before that. I'll actually just take it off for this test. I'm not going to do any pre-testing. For the actual test, I can again run it under extension or under extensometer strain if I'd like to as a control mode. Here I'm going to do a stress relaxation, which I want to go rather fast. And I'll go at 500 millimeters per minute. And then I'll hold an extension, but I'll hold it at tensile strain of 10% for 3 minutes. Again, I could do extensometer strain of 3 minutes, but I want to just do the most controlled one. If the extensometer slipped or something, I want to actually control it at 10% for this particular example. I could, again, put extensometer strain in there, which would be the true local strain. And then I'm going to hold it for 3 minutes. Now, in my workspace, I would like to display what's happening here, so I'll have my load and extension over time for my stress relaxation test, but I'm also adding an extra graph in here to show you the tensile strain versus extensometer strain. And I can take the data, the raw data, both extensometer strain and tensile strain, and look at those later. Now I go up to my test, I type in that this is leather, my company here. I have my safety stop set properly, I have my safety glasses on, everything's out of the way. I can measure the length of my sample. This is again for measurement of strain. It's 139 millimeters. I said I already know the thickness and the width. And I can go at different rates here. I think I'll actually go a little bit slower rate right now, so you can watch the extensometer strain versus regular strain. And I'll stop at 10% strain. Again, this is not extensometer strain, but the calculated strain, but I could use either one. I've already zeroed the tensile strain, and so I can start my test. Here we show here the tensile strain is calculated on the x-axis, and the extensometer strain is on the y-axis, and you can see it starts slightly negative, but they're actually following each other very well. It is now stopped at a tensile strain of 10%, but the extensometer strain is only 9%. They're not. It's a little bit less. The local strain is often smaller than the calculated strain because the extensometer strain is actual strain local, and the tensile strain has stress concentrations at the top and the bottom of the sample. Again, this is a stress relaxation test, so you can see here the strain rises and then is held at 10%, 0.1, but the extensometer strain is only 0.89. So when I do my calculations on with stress-strain relationships or strain at hold versus stress, the extensometer strain is actually going to give me a more accurate number. Now, the caveat of doing this stress relaxation test is that an optimal stress relaxation test would actually run infinitely fast, but we'll have to compensate for that computationally by integrating the signal. So that is how you use an extensometer. You can stop this test and return to 0. The extensometer went to very close to 0 strain, and the tensile strain is very close to 0 strain. So pretty good correlation between the two. And to take off the extensometer, again, I want to hold on these points and lock it into its gauge length using 2 fingers pull away the wires, and now I've removed it. Again, if I were doing a failure test on this sample, I would want to put a stop in there so that I could get the sub-failure properties with the extensometer, but once I get to the end of the sub-failure and I'm going towards failure, I'll want to stop the test, pull off the extensometer, and then go to failure, or I could break the extensometer. And that's the end of our mini discussion on how to use a extensometer.